Let's look at graphing quadratics again. So this time we got the quantity x minus 2 squared plus 1. And by the way, I mean, there's other ways you can graph this too. You can graph it with transformations where you could take a parabola, go right 2, up 1, right 2, up 1, and do that graph. And I'll go through these steps again that they showed you in notes. You can also do this in your calculator as well. So the first step in the notes is determine the value of A. A is the coefficient or the value in front of the squared term here. And so in this case, it's positive 1. It's positive. So in this case, A is greater than 0. So since A is greater than 0, then it's going to be going upward. Okay. Next, determine the vertex. The vertex is the opposite. Remember, the x in the vertex is the opposite of what's in here. The y in the vertex is just whatever's out there. So my vertex is 2, 1. I'll label that 2, 1. Didn't label that on the last one either. Okay, and so like that. The x in the vertex, we call it h, and then the k is just matching up the forms here, okay? H and k. I know that's a little confusing. I'm trying to not make this super confusing, but we're not doing the best job here. Now, to find the x-intercepts, remember we make y equals 0. So to find the x-intercept, make y equals 0. F of x and y are the same thing. So 0 equals x minus 2 squared plus 1. So now we'd subtract 1, subtract 1. This one's going to have an interesting scenario on this one. We're going to talk through square root, plus or minus. Now, remember, we have the negative. You take out an I. And so that would be, and then square root of 1's 1. So this would be plus or minus I. And I'm going to rewrite this I'm going to put the x minus 2 on the left side. Plus or minus I. Now, this will kind of run into an interesting situation. I'm going to go ahead and solve this. Remember, when you add 2 to it in front, so this would be 2 plus or minus I. Are those like terms? No. One's a number, and one's an imaginary number. And so here's the thing. My solutions are 2 plus I, 2 minus I. Okay, so I don't have just real numbers here. I have a complex number with a real part and an imaginary part. Now, when I is involved in one of your solutions, what does that mean? That means there are no real solutions. And so if there's no real solutions, that means this graph will never cross or touch the x-axis. So this one's never going to cross or touch the x-axis. So we're going to have no x-intercepts here. All right, so now let's find the y-intercept. Okay, and I'm going to try to box this in. I'm going to do it down here. So to find the y-intercept, make x equals 0. All right, so I'm going to make x equals 0. So f of 0 is equal to 0 minus 2 squared plus 1. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 plus 1 is 5. So the y-intercept is 5. So the y-intercept is 5. Okay. And then plot any additional points as necessary. So on this one, basically what happens here is this is your it's going to open upward. So it opens upward, and then this is there's no x-intercept. So your only points we have to work with are this and this. So you can go plot. Now it's not going to be, if there was multiplying by a number bigger than 1, here in front, it would make it, make it narrower. If there's a number between 0 and 1, and make it wider. So you do have those things to look at. You could, as I said, you could have also used the transformations from the parent function. Minus 2 plus 1. Minus 2 to the x means right 2, and then plus 1 at the end, it means plus 1. You could have gone that route. And you could also look at your calculator as well. So there's a lot of ways to graph this. I'm trying to show you the different ways. You don't have to you could also make a table. Another common way to do it is to make a table, and so that's what a lot of people do as well. So anyways, there's a look at your graph. And so I always like having the calculator there to check my answer and make sure I'm doing it right.